Since the beginning of human memory, the earth has never been still. Beneath our feet, beneath the soil we build our homes upon and the mountains we climb, there is a restlessness that never ceases. This restlessness reveals itself most dramatically in the form of earthquakes. When the ground trembles, when cities shake, when oceans rise in the form of tsunamis, humanity is reminded that the earth is not a dead rock floating silently in space, but a living, breathing planet, constantly reshaping itself through immense geological forces. To understand why earthquakes occur, one must first grasp that the earth is not solid in the way it appears to our eyes. Beneath the thin crust that we walk upon lies a mantle of semi-fluid rock that moves slowly but powerfully, driven by heat from the Earth's core. This slow movement, called convection, pushes and pulls on the plates of the crust, the vast puzzle pieces we call tectonic plates. They collide, separate, and slide past each other, and it is at their boundaries that the Earth's restlessness becomes most visible. When two plates grind against one another, stress builds up over decades or centuries. The rocks resist, holding together until the pressure grows too great, and then suddenly they slip. This sudden release of energy sends shockwaves through the ground, waves of destruction that travel across vast distances. To those living on the surface, it feels like the earth itself has turned against them. Buildings collapse, mountains crack, and sometimes entire cities are reduced to rubble in moments. Yet what is terrifying to us is simply the Earth's way of releasing energy, a natural process that has been happening for billions of years, long before humans existed, and will continue long after we are gone. Earthquakes vary greatly in their size and impact. Some are so small they pass unnoticed, their vibrations too faint for human senses, detected only by delicate instruments called seismographs. Others are so catastrophic that they reshape entire regions and change the course of history. Consider the earthquake that struck Lisbon in 1755, a disaster that not only killed tens of thousands but also shook the philosophical and religious foundations of Europe. Or the Great Kanto earthquake of 1923 in Japan, which destroyed Tokyo and Yokohama and led to massive social and political upheavals. These events reveal that earthquakes are not just geological curiosities but forces that shape civilizations, economies, and cultures. The restlessness of the earth is not confined to land alone. Under the oceans, earthquakes occur with equal or greater frequency. When tectonic plates shift under the sea, they displace enormous amounts of water, creating towering waves known as tsunamis. These waves can travel across entire oceans, striking distant shores with devastating force. The Indian Ocean tsunami of 2004, triggered by a massive undersea earthquake, killed more than 200 people across multiple countries, reminding humanity of its vulnerability to the hidden movements of the Earth's crust. To call the Earth restless is not mere poetry, it is a scientific truth. Every year, millions of earthquakes occur worldwide, though most are too small to be felt. The United States Geological Survey records around 20,000 significant earthquakes annually, and seismologists estimate that hundreds of thousands more go undetected. The Earth's crust is constantly in motion, constantly breaking, shifting, and settling. It is as though the planet has a pulse, a rhythm of destruction and renewal, and yet this restlessness is not purely destructive, it is also creative. Without the shifting of tectonic plates, there would be no mountains, no valleys, no ocean trenches. The Himalayas, the tallest mountains on Earth, were born when the Indian plate collided with the Eurasian plate, and they continue to rise slowly even today as the plates push against each other. Volcanoes, too, are born of this restlessness, as molten rock escapes from beneath the crust. Though they bring devastation when they erupt, volcanoes also create new land, fertile soil, and minerals that sustain human life. Thus, the very same forces that cause earthquakes are also responsible for the beauty and richness of our planet. Human beings, however, experience this restlessness primarily as a threat. For those living in regions prone to earthquakes, Japan, Chile, Turkey, California, Pakistan, the possibility of disaster is never far away. Buildings must be designed to withstand shaking, emergency drills become a way of life, and the memory of past catastrophes hangs heavy over each generation. Yet even in regions where earthquakes are rare, the fear exists, for the earth is unpredictable, and no place is truly safe. What makes earthquakes particularly frightening is their suddenness. Unlike hurricanes, which can be tracked for days, or volcanoes, which often give warning signs before eruption, earthquakes strike without notice. One moment, life continues as usual; the next, the ground shakes violently and chaos erupts. This unpredictability has led humans to associate earthquakes with divine wrath, fate, or destiny. Ancient cultures often saw them as messages from the gods. In Greek mythology, earthquakes were attributed to Poseidon, the god of the sea, who also bore the title Earth Shaker. In Japan, folklore spoke of a giant catfish, Namezu, thrashing beneath the ground. These stories reflect humanity's struggle to make sense of the Earth's uncontrollable power. In modern times, science has replaced myth with measurement. Seismology, the study of earthquakes, has revealed much about their causes and patterns. Scientists have built networks of sensors to detect tremors, satellites to measure crustal shifts, and computer models to predict risks. Yet despite all this progress, predicting the exact time and place of an earthquake remains beyond our reach. At best, we can calculate probabilities and prepare accordingly. The restlessness of the Earth continues to elude complete human understanding, reminding us that nature still holds power over us. Interestingly, the Earth's restlessness also connects to its deep history. Geological evidence shows that earthquakes have been shaping the planet since its earliest days. Fossilized fault lines, tilted rock layers, and ancient mountain ranges are all records of seismic events that occurred millions or even billions of years ago. These events have influenced the evolution of life itself. By reshaping landscapes, earthquakes and tectonic movements have created new habitats, isolated species, and influenced patterns of migration. The diversity of life on Earth owes much to the planet's shifting crust. Without earthquakes, the Earth might have been a flatter, less varied, and less hospitable world. In the present, however, the multiplying nature of earthquakes has raised new concerns. Some researchers have suggested that human activity may be contributing to seismic restlessness. The injection of fluids into the ground during oil and gas extraction, known as fracking, has been linked to increased earthquake activity in certain regions. Large reservoirs created by dams have also been associated with induced seismicity, as the weight of the water alters the stresses in the crust. This suggests that while earthquakes are natural phenomena, human actions can influence their frequency and intensity. The Earth's restlessness, it seems, can be stirred not only by tectonic forces, but also by our own interventions. Beyond the scientific and practical dimensions, earthquakes also carry profound philosophical meaning. They remind us of the fragility of human existence. In moments of shaking, all illusions of control vanish. The strongest skyscraper, the mightiest army, the wealthiest nation, none are immune when the ground itself betrays them. This humbling reality has often inspired reflection on humanity's place in the universe. Are we masters of the Earth, or merely temporary guests on a restless planet that cares nothing for our ambitions? The answer perhaps lies in how we respond. Throughout history, humans have shown remarkable resilience in the face of earthquakes. Cities have been rebuilt, societies have adapted, and knowledge has been passed down. The people of Japan, for instance, have lived with frequent earthquakes for centuries, developing architecture, culture, and traditions that embrace the Earth's restlessness rather than deny it. This resilience reflects an important truth. While we cannot stop the Earth from moving, we can learn to live in harmony with its movements. The restless Earth, then, is both a danger and a gift. It threatens us with destruction, yet it also sustains the dynamism of life. It humbles us with its unpredictability, yet it also challenges us to grow stronger and wiser. Earthquakes, as terrifying as they may be, are part of the grand story of a planet that is alive, evolving, and deeply interconnected with the cosmos. Each tremor, each fracture, each eruption is a reminder that we inhabit a world in motion, a world whose restlessness is both its curse and its beauty. As we stand on the solid ground of our daily lives, it is easy to forget this. We build our homes as if they will last forever. We plant our cities as if the earth will always remain still beneath them. But the truth is otherwise. The earth is not fixed. It is restless, and it always will be. To live wisely on such a planet is to respect this restlessness, to prepare for its consequences, and to marvel at its power. For in the end, the shaking ground beneath our feet is not an enemy to be defeated, but a teacher, reminding us that life itself is born of movement, change, and the unending dance of the restless earth. In the vastness of space, where stars burn silently and galaxies drift like islands in an endless ocean, sometimes there comes a traveler from afar, an object not born in our solar system, but arriving from distant, unknown places. Such a traveler is 3I/Atlas, the third known interstellar object detected by humankind. Its very presence challenges our understanding of the cosmos, for it reminds us that our solar system is not sealed off but open, a small neighborhood on the edge of a much larger universe where visitors can pass through at any time. 3I/Atlas is no ordinary comet. Unlike the many icy wanderers that orbit the sun in familiar ellipses, bound to our star since the early days of planetary formation, this object was born elsewhere. It comes from beyond the reach of the sun's gravity, ejected from its original star system by some ancient event, and left to wander the interstellar void for perhaps millions or billions of years before crossing paths with us. To think of such a journey is to feel both awe and insignificance. A tiny fragment of rock and ice cast adrift in the galaxy has now arrived to remind us of the immensity of time and distance. When scientists first detected 3I/Atlas, excitement spread through the astronomical community. Only once before had an interstellar visitor been seen, 1I/Oumuamua, discovered in 2017, a mysterious, elongated object that sparked debate about whether it was a natural rock or something more artificial. 3I/Atlas followed in its footsteps, proving that interstellar wanderers are not rare accidents, but perhaps regular messengers from other star systems. Each one carries with it clues about the environments in which they formed: dust, ice, organic molecules, and structures that may be different from what we find in comets native to our solar system. In this way, they are like messages in a bottle, drifting across the galactic sea, waiting to be read by curious civilizations. The comet's designation tells a story of its discovery. The 3I marks it as the third recognized interstellar object, and Atlas refers to the asteroid terrestrial impact last alert system, the survey that spotted it. This telescope network, designed to detect potentially hazardous asteroids, instead caught sight of a rare cosmic visitor, proving that even tools meant for our immediate defense against space rocks can stumble upon discoveries of cosmic scale. The excitement of astronomers was not just about finding a new comet, but about peering into the unknown. Here was matter that had never before interacted with the sun, untouched by our solar system's radiation and winds. Its chemistry and structure might hold secrets about distant regions of the galaxy, places we may never reach with spacecraft. What makes 3I/Atlas so fascinating is not only its origin, but its potential influence as it passes near our star. Some researchers speculated that its interaction with the sun could awaken new activity. Comets, when heated by sunlight, release gas and dust, creating luminous tails that stretch for millions of kilometers. This release is a form of energy exchange. Though a single comet seems tiny compared to the sun, the idea that interstellar material might interact with solar activity sparks curiosity. Could such visitors play a role in nudging the sun, however slightly, out of its regular rhythms? Could their passage alter the delicate balance of particles and fields that link the sun to the earth? While these questions may seem speculative, they arise from a deeper truth. Our solar system is not closed, and outside influences may sometimes stir its dynamics in ways we do not yet fully understand. The cosmic visitor also forces us to confront the fragility of human knowledge. For centuries, we believed comets to be omens, fiery messengers from the heavens foretelling disaster or change. Only in recent centuries did science reveal them to be icy remnants of planetary formation, leftovers from the birth of our solar system. Yet now, with interstellar comets like 3I/Atlas, we are reminded that not all comets are local. Some are truly foreign, bringing with them matter from stars we cannot even name. This deepens the sense of mystery. Perhaps within their frozen cores lie molecules that formed under alien suns, chemical traces of conditions very different from our own. Perhaps they even carry the building blocks of life from places we will never visit. If panspermia, the theory that life can be seeded across the galaxy by comets and asteroids, is true, then visitors like 3I/Atlas could be part of that cosmic story. Astronomers rushed to study the comet with every instrument available. Spectroscopy, which breaks down light into its components, allows scientists to identify the materials within the comet's coma, the glowing cloud that surrounds it. By comparing these signatures with those of solar system comets, we can identify differences that hint at its alien origin. Some early studies suggested that 3I/Atlas may have been more fragile than expected, breaking apart under the sun's heat. This fragility itself is a clue telling us something about the processes that shaped it in its home system. Perhaps it was born around a faint star, or perhaps it was ejected early from its birthplace before its ices could compact and harden. Each possibility opens new avenues for thought about how planetary systems form and evolve, but beyond the scientific intrigue lies something more poetic. The arrival of an interstellar comet reminds us that the galaxy is not a silent void but a place of movement and exchange. Systems do not exist in isolation. Just as seeds are carried by the wind across fields, so too are rocks and ices carried across the galaxy by gravity and time. A star passing near another star can sling objects outward, and those objects can wander for ages until, by chance, they enter another system. In this way, material is shared across the Milky Way, connecting distant suns in a slow, invisible dance. 3I/Atlas, then, is more than just a comet. It is a symbol of cosmic interconnectedness. Its passage through our solar system is brief on human timescales, but it resonates with a sense of eternity. The comet has likely been traveling for millions of years. By the time it leaves us and resumes its journey into interstellar space, humanity may have changed in ways we cannot imagine. It is a reminder of our smallness, but also of our potential. If such objects can cross the gulfs between stars, might we someday do the same? Might we follow their path outward, exploring not only with our instruments but with our presence? Of course, the comet also awakens ancient fears. Humanity has long been uneasy with celestial visitors. A blazing comet in the night sky, brighter than the stars, often stirred panic in past ages. Kings feared them as omens of doom, common people prayed to be spared, and records of disasters were often linked to their appearance. Even today, despite our scientific understanding, comets stir something primal in us, a sense of awe mixed with dread. The idea that 3I/Atlas might influence the sun, and through it the Earth, adds to this unease. While most scientists are cautious, some speculate about increased solar storms, geomagnetic disturbances, and even possible effects on seismic activity on Earth. Whether or not these fears are justified, they reflect humanity's deep awareness that we are at the mercy of cosmic forces. In the end, the true significance of 3I/Atlas may lie not in measurable effects, but in its symbolism. It is a messenger carrying news from beyond, reminding us that the universe is alive with motion and exchange. It forces us to confront questions that reach beyond geology or astronomy into philosophy and meaning. What does it mean that material from distant stars can touch our lives? What does it mean that our solar system is not alone but part of a galactic ecosystem where objects and energies mingle? The comet challenges us to see ourselves not as isolated beings on a quiet planet, but as participants in a vast cosmic drama. When future generations look back, they may see the discovery of interstellar objects like 3I/Oumuamua and 3I/Atlas as turning points in human thought. Just as the discovery of other planets expanded our sense of the universe, so too do these objects expand our sense of connection to the galaxy. They tell us that the boundaries between star systems are not absolute. They hint that the galaxy is not a collection of isolated islands but a web of interactions. For scientists, these discoveries are opportunities to study matter from beyond. For philosophers, they are opportunities to reconsider humanity's place in the cosmos. For ordinary people, they are sparks of wonder in the night sky, proof that the universe still holds surprises. As 3I/Atlas continues on its journey, it will fade from our view, shrinking back into the darkness of interstellar space. Yet its memory will remain, written in the data gathered by telescopes, in the papers of scientists, and in the imaginations of all who gazed upon it. Long after it has gone, the questions it raised will endure. And perhaps one day another such visitor will arrive, carrying new mysteries, offering new opportunities to learn and to dream. Until then, 3I/Atlas stands as a reminder that we are part of a living galaxy, where even the smallest fragments of ice and dust have stories to tell, stories written across light, years, stories older and larger than humanity itself. The sun, our star, the blazing heart of our solar system, has been the giver of life and the sustainer of all energy on Earth since the dawn of time. Every blade of grass, every breath of air, every heartbeat is linked to the sun's power. Yet this mighty star is not constant in its behavior. It does not shine with mechanical regularity like a machine switched on and forgotten. Instead, the sun has moods, rhythms, and cycles. It passes through periods of calm when its face is smooth and quiet, and then it awakens into stormy activity, flaring and boiling with magnetic energy. To understand the sun's cycles is to understand not only the star itself, but also the profound ways in which it influences life on Earth. At first glance, the sun appears unchanging. To the naked eye, it is a constant golden disk in the sky, rising and setting every day without fail. But telescopes, spacecraft, and centuries of observation have revealed a different story. The sun is in constant motion, its surface a churning ocean of plasma, its atmosphere alive with magnetic fields that twist, snap, and reconnect in violent outbursts. The most visible sign of these changes is the appearance and disappearance of sunspots, dark patches on the solar surface that mark regions of intense magnetic activity. The number of sunspots rises and falls in a regular rhythm, roughly every 11 years, in what we call the solar cycle. When the sun is quiet at the bottom of its cycle, sunspots are few or absent, solar flares are rare, and the solar wind, a stream of charged particles flowing outward into space, is relatively steady. This is when the sun sleeps. Earth during these times enjoys fewer disturbances from space weather, though even in its calmest state, the sun's energy continues to drive climate, weather, and ecosystems. But as the cycle rises, the sun awakens. Sunspots multiply, sometimes covering large portions of the solar surface. Solar flares, sudden bursts of radiation, erupt with greater frequency. Coronal mass ejections, giant clouds of charged particles, are hurled into space at millions of kilometers per hour. The solar wind becomes more turbulent. In these active times, the sun is restless, and its influence on Earth grows more dramatic. The connection between the sun's cycles and life on Earth is both fascinating and sobering. On the beautiful side, solar activity is responsible for the dazzling auroras, the northern and southern lights, that paint the skies near the poles with shimmering curtains of green, red, and purple. These lights occur when charged particles from the sun strike Earth's atmosphere, exciting atoms and making them glow. But alongside beauty comes danger. Strong solar storms can disrupt satellites, interfere with GPS, damage power grids, and endanger astronauts in space. In 1989, a solar storm knocked out power across much of Quebec, plunging millions into darkness. Even more dramatic is the memory of the Carrington event of 1859, the most powerful solar storm ever recorded, which lit the skies with auroras visible as far south as the Caribbean and caused telegraph systems to spark and fail. If such an event were to happen today in our technology-dependent world, the consequences could be catastrophic, with global communication, navigation, and power systems severely disrupted. Yet the influence of solar cycles goes beyond technology. There is evidence that the sun's activity can subtly affect Earth's climate. During the Maunder Minimum, a period in the 17th century when sunspots were exceedingly rare, Europe experienced the Little Ice Age, with colder winters and shortened growing seasons. While climate is influenced by many factors, volcanoes, greenhouse gases, ocean currents, the role of the sun cannot be dismissed. Its cycles may not dictate weather day by day, but over decades and centuries they leave their fingerprints on Earth's climate history. Scientists have spent decades trying to understand the deeper cause of the sun's cycles. At the heart of the mystery is the solar dynamo, the process by which the sun's rotation and convection generate its magnetic field. The sun does not rotate like a solid ball; its equator spins faster than its poles. This differential rotation twists and tangles the magnetic field lines, building up energy until it must be released. Sunspots, flares, and eruptions are the visible manifestations of this hidden dynamo. Why the cycle lasts about 11 years is still not fully understood, though it appears linked to the periodic flipping of the sun's magnetic polarity. At the peak of each cycle, the sun's magnetic north and south poles switch places, a process as mysterious as it is majestic. This rhythm of sleeping and awakening is not just an astronomical curiosity, it is part of the deep relationship between Earth and its star. Humans have lived under the sun's cycles for millennia, often without realizing it. Farmers, sailors, and kings once made decisions based on the behavior of the sky, though they lacked the tools to understand the underlying processes. Today, with satellites and observatories, we can monitor the sun with exquisite precision. Spacecraft like the Solar Dynamics Observatory and the Parker Solar Probe send back breathtaking images and data, revealing the sun's surface in detail never seen before. These missions show us that even in its quietest moments, the sun is alive with motion, waves of plasma rising and falling, magnetic loops arching into space, explosions occurring on scales beyond imagination. And yet, despite all our knowledge, the sun retains its mystery. Predicting its cycles with accuracy remains a challenge. Sometimes the sun enters prolonged quiet phases, as during the Maunder Minimum. At other times it erupts with unexpected intensity. The solar maximum of one cycle is not always the same as the next. This unpredictability has implications for Earth, for our technology, and even for our sense of security. We are tied to the moods of a star, and though we may try to master nature, the truth is that we are still vulnerable to forces far beyond our control. To speak of the sun sleeping and awakening is more than metaphor. It is to recognize that stars, though vast and powerful, are dynamic entities with their own lives and rhythms. The sun, like all stars, was born from a cloud of gas and dust billions of years ago. It burns now in middle age, sustaining us with steady light. But its cycles of activity remind us that even stars are restless, their energy forever shifting and reshaping. For Earth, this restlessness is both blessing and threat. Without the sun's dynamism, we would not have the protective shield of the solar wind that helps keep dangerous cosmic rays at bay. Without its cycles, the magnetic fields of Earth might evolve differently. But with its dynamism comes risk, the risk of storms that could humble even our most advanced civilizations. Human imagination has always been captivated by the sun's moods. Ancient peoples tracked sunspots with the naked eye during solar eclipses, noting times when the sun seemed blemished. In many cultures, solar storms and unusual lights in the sky were interpreted as omens, warnings of war, famine, or divine displeasure. Today we interpret them through science, but the awe remains. To look at an image of a solar flare, an eruption of energy larger than the Earth itself, is to feel the same mix of wonder and fear that our ancestors felt. The sun is both our life giver and a reminder of our fragility. As we move into a new age of technology and exploration, the importance of understanding the sun's cycles grows. Satellites orbiting Earth, probes traveling through space, astronauts on the International Space Station, and future missions to the Moon and Mars all depend on knowing when the sun will awaken. A solar storm could endanger astronauts beyond Earth's protective atmosphere or disable spacecraft traveling far from home. Thus, monitoring the sun is not just an academic pursuit, but a necessity for survival in the spacefaring era. The cycles of the sun also speak to a larger truth about the universe. Nothing in the cosmos is truly static. Stars pulse, planets shift, galaxies collide. The sun's sleeping and awakening are local examples of the universal principle of change. Just as the earth is restless beneath our feet, the sun is restless above our heads. Both remind us that stability is an illusion, that all things are in motion, and that life itself arises not from stillness but from dynamic interplay. Perhaps one of the most humbling realizations is that while we often think of ourselves as masters of technology and architects of our destiny, we remain deeply dependent on the cycles of a star. If the sun were to alter its rhythm significantly, if it were to fall into an unusually long quiet phase or awaken with unprecedented fury, our world would be transformed. Climate, power systems, communication, agriculture, all would feel the effects. In this sense, we are not separate from the cosmos but bound to it, shaped by it, and forever subject to its rhythms. The sun's cycles, then, are not just astrophysical curiosities, they are living reminders of our dependence on forces greater than ourselves. They teach us humility, resilience, and curiosity. They invite us to prepare for challenges while marveling at beauty. They show us that the line between calm and chaos, between life and destruction, is often as thin as the boundary between a sleeping sun and an awakened one. And as we look to the future, the study of these cycles will continue to shape our survival, our exploration, and our understanding of what it means to live beneath a star that sleeps and awakens with eternal rhythm. From the very beginning of human history, people have looked to the heavens and wondered whether events in the sky could influence life on Earth. Eclipses, comets, planetary alignments, all have been interpreted as signs, warnings, or causes of earthly change. For centuries, these interpretations were woven into myth and religion, dismissed later by science as superstition, and yet, as our understanding of the cosmos has grown, it has become clear that Earth is not an isolated stage where life unfolds untouched by the greater universe. The truth is that cosmic forces do influence Earth, sometimes subtly and sometimes violently, shaping the conditions under which life and civilization must endure. This understanding forms the foundation of the question, could the interstellar visitor 3I/Atlas, in its journey through our solar system, be disturbing the sun in ways that indirectly affect the Earth? To imagine such a possibility requires first acknowledging the profound interconnectedness between the Earth and the sun. Earth's climate, atmosphere, magnetic field, and even its geological rhythms are tied to the behavior of our star. When the sun sleeps, its calm is reflected in the gentle regularity of space weather. When the sun awakens, its storms can ripple through the solar system, agitating magnetic fields, disrupting satellites, and sometimes even stirring the delicate balance of Earth's tectonic plates and weather systems. The chain of influence is complex. Energy from the sun travels in the form of light, heat, and charged particles, interacting with our planet in countless ways. If something like 3I/Atlas can alter the sun's state of activity, even slightly, then Earth may feel the reverberations in unexpected forms. The notion of a comet influencing the sun might at first seem far-fetched. The sun is vast, unimaginably powerful, dwarfing even the largest comet. How could a fragment of ice and rock, even one from interstellar space, make any difference to a star that contains 99.8% of the solar system's mass? The answer does not necessarily lie in sheer size, but in interaction. When a comet approaches the sun, its ices vaporize, releasing clouds of gas and dust. This material can interact with solar winds and magnetic fields, sometimes triggering localized instabilities. If 3I/Atlas carries unusual compounds from its alien origin, it could influence the sun in ways unlike ordinary comets. Furthermore, as an interstellar object, its trajectory and speed are unlike those of comets bound to the sun's orbit. Its very strangeness makes it difficult to rule out possible effects. Throughout history, there have been curious correlations between cosmic events and earthly upheavals. Strong solar storms have been linked to disruptions in Earth's magnetic field, which in turn have subtle effects on the crust, atmosphere, and possibly even the frequency of earthquakes. While the direct mechanism is debated, scientists acknowledge that Earth is sensitive to changes in solar output. If the arrival of 3I/Atlas has nudged the Sun into greater activity, then we must at least consider the possibility that Earth's systems are responding. Imagine a chain reaction. The comet passes through the inner solar system, stirring solar energy. The Sun awakens, releasing flares and coronal mass ejections. Earth, caught in this storm of particles and radiation, feels the stress in its magnetic shield, its climate, and perhaps even in locked tension of tectonic plates. Skeptics will point out that comets are small, and the Sun is too massive to be disturbed in any measurable way. But science is often advanced by exploring unlikely questions. Centuries ago, it seemed absurd to think that a rock could fall from the sky, and yet meteorites proved otherwise. It seemed unimaginable that tiny microbes could alter entire ecosystems, yet we now know of their profound influence. Perhaps one day we will discover that cosmic visitors, rare and fleeting, play subtle roles in the cycles of stars and planets. 3I/Atlas, as an emissary from another star system, might bring with it energies, materials, or gravitational perturbations we do not yet understand. The idea of cosmic influence is not limited to 3I/Atlas. Earth has always been shaped by forces from beyond. Asteroid impacts have caused mass extinctions, as with the event that ended the reign of the dinosaurs. Variations in Earth's orbit and tilt caused by gravitational tugs from other planets have influenced the cycles of ice ages. Cosmic rays from supernovae may alter atmospheric chemistry and even play roles in genetic mutation. The galaxy itself moves through regions of varying density, and some scientists speculate that this too could influence Earth's climate and life. Against this backdrop, the notion that an interstellar comet might stir the Sun and indirectly influence Earth does not seem so outlandish. If such influence exists, what might it look like? One possibility is an increase in solar activity, more sunspots, stronger solar flares, and heightened coronal mass ejections. This in turn could lead to more geomagnetic storms on Earth. These storms disturb the ionosphere, affecting radio communication, navigation systems, and power grids. They can also produce breathtaking auroras, but the beauty masks their disruptive power. On a more speculative level, changes in geomagnetic stress might influence Earth's crust. Some studies have suggested weak correlations between geomagnetic storms and seismic activity, though the evidence is inconclusive. Still, the possibility invites thought. Could Earth's earthquakes, multiplying in recent years, be connected not only to tectonic processes but to cosmic rhythms triggered by the Sun's awakening? The poetic imagination has long entertained such connections. Ancient cultures often linked comets to earthquakes, famines, or plagues. While these interpretations were symbolic, they reflect an intuition about interconnectedness, that events in the sky and events on Earth are part of a larger whole. Today, with science, we can frame the question more precisely. We no longer see comets as omens of doom, but we do recognize them as carriers of energy and matter, as actors in the cosmic play. 3I/Atlas, arriving from the darkness between stars, may be one of those rare actors whose role, though small, shifts the balance of the stage. If nothing else, the speculation about 3I/Atlas reminds us that Earth is vulnerable. We tend to think of our planet as secure, shielded by its atmosphere and magnetic field, but history shows otherwise. Solar storms, impacts, and cosmic events have reshaped Earth many times. Our technological civilization is especially vulnerable, reliant on fragile networks of power and communication that can be disrupted by even modest solar disturbances. If the Sun is indeed entering a more active phase, nudged or not by 3I/Atlas, then humanity must be prepared for consequences. Satellites must be hardened against radiation, power grids must be shielded, and societies must recognize that their infrastructure is tied not only to earthly forces, but to the moods of a distant star. And yet, there is wonder alongside the caution, to think that an object born around another star, perhaps flung out during the formation of alien planets billions of years ago, could now be influencing our Sun, and through it our world, is to glimpse the unity of the cosmos. It is to see Earth not as an isolated island but as part of a galactic web, where matter, energy, and destiny are shared across unimaginable distances. Whether or not 3I/Atlas is truly stirring the sun, the very act of asking the question deepens our awareness of this unity. In the future, as our instruments grow more precise, we may be able to detect more interstellar visitors, track their effects, and learn whether they leave measurable imprints on solar or planetary behavior. Perhaps we will find that most pass unnoticed, silent wanderers on endless journeys. Or perhaps we will find that occasionally one awakens subtle reactions, ripples that spread from the sun to the earth and beyond. If so, then each comet becomes a thread in the tapestry of cosmic influence, a reminder that even the smallest traveler can play a role in the grand design. For now, 3I/Atlas has already left its mark in the realm of imagination. Scientists debate, poets dream, and ordinary people gaze at the sky with renewed curiosity. Whether it is truly disturbing the sun or simply passing by, it has awakened in us the ancient sense of connection between the heavens and the earth. And perhaps that is its greatest influence, not in the sun's magnetic fields or Earth's seismic tremors, but in the human heart, which longs to find meaning in the dance of the cosmos. When we think about the workings of the universe, it is tempting to separate events into neat categories. There is the realm of comets, far out in space. There is the realm of the sun, burning at the heart of our solar system, and there is the realm of the earth, solid beneath our feet. But reality does not divide itself so neatly. Forces flow from one realm to another, weaving invisible threads that connect distant phenomena into one great system. A chain reaction is the natural language of the cosmos. The flutter of a comet's tail may not immediately appear to concern the foundations of human cities, yet when we trace the sequence of influence, from comet to sun, from sun to earth, from earth to its trembling crust, we begin to glimpse how interconnected the story truly is. The arrival of 3I/Atlas into our solar system is not just a passing event, it is a disruption. Like a stone dropped into a pond, its presence creates ripples that extend outward. Unlike most comets we know, which belong to the sun's family and follow predictable elliptical paths, this one is an interstellar visitor, born around another star, shaped by alien conditions, carrying with it the memory of distant worlds. Its composition may be unlike anything we have seen. When such a body nears the sun, it introduces new interactions. Its gases and dust, vaporizing under solar heat, can alter the environment around the star, stirring turbulence in the solar wind, tweaking the flow of charged particles, and perhaps even nudging the sun toward greater activity. Imagine the sun as a great sleeping lion. For long stretches of time, its energy ebbs and flows in regular cycles, marked by the quiet rhythm of sunspots and flares. But occasionally, an external prod can rouse it more abruptly. If 3I/Atlas carries with it magnetic fields or unusual chemical compounds, if its sheer gravitational pull in passing adds even a tiny perturbation, it may be enough to awaken the lion. Once stirred, the sun does not roar quietly. It erupts with energy, flinging plasma into space, accelerating particles, and lighting up the heliosphere with storms of unimaginable force. The Earth, small and vulnerable, lies directly in the path of these outbursts. When the sun becomes active, the first to feel the brunt are Earth's protective shields, the atmosphere and the magnetic field. Solar flares and coronal mass ejections bombard the magnetosphere, compressing and shaking it. This stress cascades downward, altering currents in the ionosphere, disturbing satellites, and sending geomagnetically induced currents through power grids. While these effects are well known, there is a deeper question. Could such disturbances also influence the solid Earth itself? Some scientists have observed patterns suggesting a faint correlation between solar storms and seismic events. The mechanism is not fully understood, but one possibility is that fluctuations in the geomagnetic field and induced currents stress fault lines already under pressure, triggering earthquakes that were poised on the edge of release. If this is true, then the chain reaction becomes clear. A comet from another star enters our solar system. Its presence disturbs the sun, which erupts in heightened activity. The Earth, bathed in this storm of solar energy, experiences stress not only in its skies and machines but deep in its crust. Tectonic plates, always shifting and grinding, may be pushed past their limits, releasing energy as earthquakes. The multiplication of tremors across the globe could thus be seen not merely as geological inevitability but as the echo of a cosmic sequence that began with the arrival of 3I/Atlas. This chain reaction is not purely mechanical but also poetic. The comet is a wanderer, a messenger from the stars. The sun is a great engine, a fiery heart that responds to the smallest stimuli with immense consequence. The Earth is a living planet, restless and dynamic, sensitive to forces near and far. Together, they form a story that transcends the boundaries of disciplines. It is astronomy, geology, physics, and mythology intertwined. To see the earthquakes multiplying in this light is to recognize that they may be part of a greater rhythm, a cosmic heartbeat that pulses through space and time. Consider the scale of this connection. The comet begins its journey perhaps billions of years ago, flung out of its home system by gravitational encounters or stellar birth pangs. For ages it drifts in the cold interstellar void, unseen, untouched. Then, by chance or fate, it crosses paths with our sun. Drawn inward, it releases its frozen cargo, its tail glowing in the solar wind. The sun, immense but sensitive, responds. Its surface churns, its magnetism flares, its energy surges outward. Earth, orbiting faithfully at just the right distance, receives the consequences. Storms of particles crash against its shields, subtle stresses ripple through its crust, and cities tremble as the ground shakes. Humanity, fragile yet aware, looks upward and wonders, could this chain reaction truly link us to a visitor from another star? Skeptics demand evidence, and rightly so. Science is built on proof, on data, on the repeatability of observations. Yet it is also true that some of the most profound discoveries began as questions that seemed unlikely. The idea that invisible waves could carry voices across oceans, that unseen particles could hold together the atom, that space itself could bend and ripple, all once sounded implausible. Perhaps the notion of a comet sparking earthquakes through a solar chain reaction will one day join them, once the instruments are sensitive enough to trace the threads. Until then, the possibility invites us to expand our sense of causation, to think not in narrow compartments but in webs of influence. The earthquakes themselves are reminders of Earth's dynamic heart. Beneath the crust, molten rock shifts and circulates, driving the motion of plates. Stress builds silently over decades, centuries, until at last it breaks free. We tend to see this process as purely internal, disconnected from the stars. But what if the timing, the trigger, is sometimes external? What if cosmic nudges determine when and where Earth releases its energy? The multiplication of quakes could then be a message not only about the restlessness of our planet, but about the larger environment it inhabits. In contemplating this chain reaction, we also confront our vulnerability. Human civilization builds upon the illusion of stability, stable ground, stable climate, stable systems. Yet stability is the exception, not the rule. The earth quakes, the sun storms, comets wander. To live on this planet is to live at the mercy of forces beyond our control. Recognizing the chain of influence does not give us power over it, but it does give us perspective. We are part of a vast system, not separate from it. Our survival depends on understanding and respecting the links that bind comet to star to planet to quake, but there is also awe in this recognition. To think that a fragment of rock and ice from a distant star could set in motion a sequence that ends with the trembling of the earth beneath our feet is to glimpse the unity of the cosmos. It tells us that nothing is truly isolated, that every action ripples outward, that the universe is a single body with countless organs, each affecting the others. This is not only science but philosophy, not only physics but spirituality. The chain reaction is a metaphor for interconnectedness itself. One day, perhaps, humanity will learn to measure such chains with precision. Instruments may detect the subtle changes in solar magnetism as comets pass, the shifts in Earth's fields as the sun stirs, the correlation between cosmic arrivals and seismic surges. Until then, we must balance skepticism with imagination, acknowledging both the limits of knowledge and the possibilities beyond. The multiplication of earthquakes in recent years may have many causes, from human induced stress to natural cycles. But it may also be part of a greater story, one that begins far beyond the bounds of our solar system. In the end, whether or not 3I/Atlas truly set this chain reaction in motion, the idea itself has power. It invites us to see earthquakes not merely as local disasters but as notes in a cosmic symphony. It reminds us that our lives are played out on a stage that stretches from interstellar space to the molten core of the Earth. It encourages humility, curiosity, and wonder, and perhaps most importantly, it makes us aware that we are part of a fragile, interconnected system where even the smallest visitor from the stars can leave echoes that reach into our world. Thus, the chain reaction stands as both possibility and metaphor. A comet awakens the sun stresses the earth quakes, and humanity trembles, not only from fear but from awe at the realization that we are bound to the universe by threads both visible and invisible, by causes both known and yet to be discovered. When we step outside on a clear night and lift our eyes to the stars, there is a natural tendency to feel small. The universe stretches out in all directions, filled with countless galaxies, each containing billions of stars, many with planets of their own. Against that backdrop, Earth seems like a fragile speck, a single world drifting through an endless void. And yet, the deeper we look into the mysteries of existence, the more we discover that Earth is not isolated, not separated from the rest of the cosmos by some impermeable barrier. Rather, it is profoundly connected, woven into the fabric of a living universe where cosmic events shape life, and where every moment is a reminder of our intimate relationship with the stars. For centuries, human beings imagined Earth as the center of all things. The sun rose and set upon us, the heavens revolved around us, and everything seemed to point inward to our little planet. Science gradually dismantled that illusion, revealing instead a universe where Earth is neither central nor particularly large. But in taking away our sense of cosmic centrality, science also gave us something greater, a recognition that we belong to a vast and interconnected system, a system in which no part is truly separate. We are not alone in our journey through the stars, but participants in a story that began long before our species existed and that will continue long after we are gone. The bigger lesson becomes clear when we realize that the Earth itself is the child of cosmic events. Our sun was born from the collapse of a giant molecular cloud seeded with heavy elements from ancient supernova. Those stars that died long before our sun existed gave us the carbon in our bodies, the iron in our blood, the oxygen in the air we breathe. Every atom in us was forged in the heart of a star, and thus we carry the memory of the cosmos within us. The Earth's rocks, mountains, oceans, and atmosphere are likewise products of this grand inheritance. To walk upon Earth is to walk upon stardust, reshaped and reborn into a living planet. But the connection does not end with origins. Cosmic events continue to shape Earth in the present. The sun's activity influences our climate, our magnetic field, and even the rhythms of life. Comets and asteroids have brought both destruction and possibility, ending the reign of dinosaurs, but perhaps also delivering water and organic molecules that made life possible. Galactic forces may play roles we are only beginning to imagine, from bursts of cosmic rays altering our atmosphere to the slow dance of the solar system through different regions of the Milky Way, exposing Earth to varying cosmic environments. These influences may not always be visible in our daily lives, but they remind us that we are never cut off, never shielded from the wider universe. We exist within its currents and tides as surely as fish live within the sea. This realization shifts our understanding of earthquakes, storms, and other natural phenomena. We tend to think of them as purely terrestrial events, products of geological or meteorological processes contained within Earth. Yet each of these may be linked in subtle ways to the larger cosmos. The tectonic plates that move beneath our feet are driven by heat that is, in part, the lingering energy of Earth's violent birth, itself shaped by cosmic collisions. The weather systems that sweep across continents are influenced by the energy received from the sun, which follows cycles of activity determined by forces far beyond our world. Even life itself is influenced by cosmic rhythms, the length of the day shaped by Earth's rotation, the seasons shaped by its orbit, the tides shaped by the moon, and perhaps even cycles of extinction influenced by movements through the galaxy. To live on Earth is to live as part of an orchestra where the music of the cosmos is always playing, sometimes softly, sometimes with a crashing crescendo. The lesson, then, is humility. Our human perspective tends to narrow itself, to focus on the immediate concerns of survival, politics, technology, and culture. But the cosmos invites us to expand that vision, to recognize that the ground beneath us and the stars above us are parts of a single continuum. Earthquakes, for example, may seem like isolated tragedies when cities fall and lives are lost. Yet, they are also signs of Earth's vitality, driven by deep forces that connect us to the formation of continents, the recycling of materials, and the maintenance of an environment where life can thrive. If those forces are influenced in turn by cosmic events, by the sun, by comets, by galactic rhythms, then even the most intimate of human experiences becomes part of a universal story. This sense of connection can inspire fear, for it reveals our vulnerability. We are not shielded from cosmic catastrophe. An asteroid could strike, a solar flare could fry our satellites, a shift in galactic environment could alter our climate, but alongside the fear is wonder. To know that we are part of something so vast is to feel awe, and awe can be the seed of wisdom. Instead of shrinking before the immensity of the cosmos, we can learn to embrace our place within it, to recognize that being connected means being alive within the grandest story ever told. The lesson also speaks to responsibility. If Earth is part of the universe, then our actions are not isolated either. The way we treat our planet affects not only ourselves, but the unfolding of life that carries forward the legacy of the cosmos. We cannot separate human activity from cosmic reality. Our industries alter the climate, which in turn interacts with solar cycles and global systems. Our exploration of space sends probes beyond the solar system, extending the reach of Earth into interstellar space. In a sense, humanity itself has become a cosmic actor, adding its thread to the fabric of interconnection. To realize this is to feel both small and significant, small in the face of the infinite, significant because our choices ripple outward into that infinity. We are reminded, too, that connection is not merely physical, but also psychological and spiritual. For millennia, humans have looked to the heavens for guidance, seeing in the stars stories of gods, heroes, and destinies. While science has replaced myth with measurable explanations, the longing to feel connected to the universe has not disappeared. It is built into our very being, as natural as breathing. Perhaps this is because we are, at the deepest level, the universe becoming conscious of itself. When we gaze at the stars, we are the cosmos looking back on its own existence. When we recognize the link between comet and sun and earth, we are recognizing ourselves in a mirror stretched across space and time. The bigger lesson, then, is one of belonging. Earth is not an orphan wandering alone, but a member of a cosmic family. Every earthquake, every storm, every burst of solar activity is a reminder that we are immersed in a universe of energy and change. The multiplication of quakes in recent times, whether caused by tectonic stresses, solar influences, or interstellar visitors, is not random chaos but part of a larger dance. To fear it is human, but to understand it is divine. Understanding lifts us beyond the immediacy of destruction into the recognition of meaning. It tells us that even in disaster, we are participating in the eternal rhythm of the cosmos. There will come a time when humanity leaves Earth, spreading outward to other planets, other systems. In that time, the lesson will become even clearer. We are not bound to one world, but to the universe as a whole. The same cosmic forces that shaped Earth will shape our new homes, and the same interconnectedness will bind us to new skies. Whether on Mars, orbiting distant exoplanets, or sailing between stars, we will always carry the awareness that we are threads in the same tapestry woven by the same cosmic loom. Even now, as we remain earthbound, we can live with that awareness. To look at the sun is to feel its warmth, but also to remember its storms. To feel the ground quake is to fear for safety, but also to recognize the vitality of a planet in motion. To hear of comets arriving from interstellar space is to marvel at journeys that span billions of years, now intersecting with our own. Each of these is a lesson, and together they form the greater truth: Earth is not isolated. It never has been, it never will be. We are connected utterly, completely, beautifully, to the universe that gave us birth. And so the earthquakes that multiply, the storms that rage, the comets that wander, and the sun that awakens are not separate stories but chapters in one book. The cosmos is the author, and we are both the characters and the readers. To live with this awareness is to live with reverence, humility, and hope. It is to know that even in our fragility, we are part of something eternal. The bigger lesson is not merely that cosmic events shape Earth, but that Earth itself is a cosmic event, and so are we. Our lives, our struggles, our triumphs are threads in the same web that stretches across galaxies. We are stardust, bound by gravity and light, held in the embrace of a universe that is alive with connection.